Hello and good afternoon, CTS267 Section 840 students for the Spring 2017 semester at Anne Arundel Community College. This is the CCNP TSHOOT course, and this evening's video tutorial is going to actually be answering a question that came up from one of our learners regarding the Secnik Challenge 2 activity, and specifically around this feature where it was the second ticket that we had to troubleshoot, which was Peter explained to you that he tried to configure a security feature where users could only establish SSH sessions to our server here, and this could be, let's say it's a web server, it could be a file server, it could be whatever, but we're trying to create an ACL that's going to allow us to connect from inside the enterprise, but nobody would be able to establish a session from the server. And the question that came up was it wasn't clear what the established keyword at the end of this ACL is doing. And so I touched on it briefly yesterday when I actually ran the first run of this video, but let's take a deeper dive here because this is actually a very important question. So we're going to talk a little bit about TCP and how the sessions are established, and this is really going to sort of go back to CCNA, and then we're going to talk about why you would use the established keyword. What kind of a use case does it give us? So if I was to say show run include, and let's say extended, because it's an extended ACL, and let's do show run access list, or actually say show run pipe include access list, because I think we've got, there we go. All right, so we've got this access list here, 111, and what does the ACL say? Well, the ACL says I'm going to permit TCP connections from the 192.168.0.0, so the /16, 192.168/16. So any TCP connections from that subnet, right, and this includes VLAN 10 and VLAN 20, to the host 172.16.210, and then we have, and I'll block that off there, so this is the from. And the way to remember the order is alphabetical, right? I always try to think of little mnemonics to help me remember. So from this subnet range to that server IP, we know that's the server IP, but then we get this keyword established. And I had commented in the actual activity, which is already posted, that it means that if we've already got an established connection, that the return traffic is going to be allowed, right? So as this ACL stands right now, we're saying because this established keyword is in here, we're talking about return traffic. And what do I mean by return traffic? Well, let's think about this. First of all, this established keyword is specific to TCP, and kind of put that all together there, TCP only. If we're talking about UDP, ICMP, that is not TCP. So this established keyword is not going to assist there. And so what does that mean? Well, remember, how does TCP, if I'm using HTTP, or if I'm using SSH, or if I'm using Telnet, and I go to establish a TCP connection, what does that connection setup look like from a packet perspective? Well, remember, so we'll say initiator, I'll say I for the initiator. The initiator is going to send a SYN packet, right? So if this is the host that I'm doing SSH off of, this host is going to send a synchronize or a SYN packet, because we need to synchronize up our packet, the numbers, right? The sequence numbers for the connection, because we're trying to set this connection up. Let's synchronize, and this is the session setup. So then you've got, I'll just say the server, right? We'll use S as the server. So the server gets that SYN packet, and what does he reply with? Exactly. He replies back with his synchronize, but he also replies back with an acknowledgement, right? So the first thing that happens is we get the initiator sends a SYN, right? So I type in telnet 172.16.210, and that is all kicked off with a SYN packet to start, right? And we're going to do a Wireshark packet capture. You're going to see this in action. So number 2, the server, right, where let's say the SSH you're trying to SSH to, he gets that synchronized packet. He responds back with his SYN packet, but he also acknowledges that the synchronization request, right? And then what's the third packet in this setup? It's going from the initiator back to the server, and it is an ACK. Now, let me ask you this. We've got the SYN, SYN-ACK, ACK, the three-way handshake. The communication, the session setup is complete after that third packet. And so let me ask you this. When will it send another SYN packet for this conversation, for this session? When will you see more SYN packets? Exactly. Kind of a trick question, right? Because the only time we send the synchronized packets is at session establishment. So when I type telnet 172.16.210 and I hit enter, that's where we get the SYN, the SYN-ACK, and the ACK. After that, and this is true for all of my TCP session setups. And remember, this is literally universal to TCP connectivity. You will always have a SYN, a SYN-ACK, and an ACK, and then after that, everything is an ACK. That's it. You don't have, for that conversation, right? Now remember, I'm talking about, I type telnet, and it does SYN, SYN-ACK, ACK, and then I'm sitting there working away with my telnet connection. There aren't going to be any other synchronized packets for that session. Now, if I fire up another window and I SSH in, yeah, that's a mutually exclusive, completely separate TCP session. So it would have its own SYN, SYN-ACK, and ACK. So again, for the conversation, once the three-way handshake is complete and I'm plugging away and I'm working, we're only going to see ACK packets. That's it. And that is what this established is all about. So one way to look at this from an ACL perspective is that the established keyword is basically saying, I'm checking every packet, and if I don't see an ACK, and to be technically correct, a reset is also allowed through, but we're going to talk about it from the ACK perspective. If I don't see an ACK, then the return traffic is not allowed to come back through. Only acknowledgments are allowed, and based off the fact that only the acknowledgments are allowed, that implies what? Exactly, that the TCP session is established. And that is what this keyword is all about. So when you read the description that Peter tried to implement a security solution to allow users from 192.168 to connect to the 172.16.200, but nobody can connect back. If you look at this ACL, right, and we look at how this is laid out, what exactly is this ACL saying? This is saying that I'm going to allow TCP connections from the 192.168, etc., to the 172.16.200 that are already established. So with this ACL applied on an interface, when you initiate, right, and I'm going to go ahead and clear this off here. When you initiate the session, right, oops, sorry, let's keep that back there. The way that ACL is written right now is saying that, and this guy right here is, these are all 192.168 something, I think it's .10 and .20 down here for the VLANs, that third octet. But when I go to initiate the SSH session, and right here on that interface, right now in the outbound direction, that ACL that we just saw is applied. But what's the first packet that's going to hit this interface in the outbound direction when we go to connect? Exactly, a SYN packet. And the established keyword at the end of that ACL mandates, right? It is mandatory that it is only going to allow acknowledgement packets for a pre-established TCP session where the SYN and the, well, actually, let's be accurate here. So the SYN came from here, and then the SYN ACL is going to make its way right down here, and then this guy's going to reply back with an ACL. So at this point, these would currently, with the way things are written, that would be allowed through, right? However, we're never going to get to that acknowledgement because the synchronization which has to take place in order for TCP to function, because again, we're talking about SSH, which leverages TCP port 22, we have to do something here in order to fix this. We'll never get to the acknowledgement packets, and therefore that's one of the reasons why this traffic is going to be dropped, right? So we're doing it backwards. We're saying from the 192.168 to the 172.16.210, right? Now, where this, and again, this is in the wrong direction. This is in the outbound direction. And we don't want connections to be initiated from the server. So what would be a good use case for this? And I kind of already hinted at it. So if we said that this is our web server, and who knows, maybe this is our DMZ, and again, we're going to put an ACL here, but we're going to configure it properly here in a second. We're going to make that change to fix things. We put an ACL on this interface. This is in the DMZ. Someone out here on the internet, right, gets in through router 1, and they're able to hack that web server. So the ACL that we have on this, or that we're going to have on that interface right there, that says that unless it's already an established connection, what you can look at it like this. It's only going to allow packets that come into that interface that are acknowledgement packets for TCP. So what does that mean? Exactly, it means that every TCP packet flowing that direction, right, has to be an acknowledgement packet that it's not going to allow, and the reason it lets that SYN ACL through is because the ACL flag is set in the SYN ACL. Because you may be thinking, well, wait a second, you just said that the SYN's not going to make it through. It's looking to see if the ACL bit is set. So the SYN kicks things off, the server replies back with a SYN ACL, and this passes the check because the acknowledgement flag is set. So it's allowed back through, and then we have ACLs, right? Then everything else is an ACL. So after session setup from the server, the only packets that are going to be flowing that direction are ACLs. And so a packet that showed up here on this interface in the inbound direction, right? So from the server, that was a SYN packet by itself. This indicates that some process here, or somebody is trying to initiate TCP connections from this server. So if this server got exploited, we want an ACL like this with the established flag to protect ourselves from a rogue hacker from then launching some sort of a TCP-based attack off of that server. Because again, every time they go to launch that TCP attack, a SYN packet is the first packet that's going to go through, and that packet is going to be dropped because it doesn't represent an already established TCP session. And so again, I mentioned in the first video sort of the directionality of things. Right now, this ACL here is in the outbound direction. That does us no good in the scenario that we're talking about. And again, great move by Peter to try to implement this, but let's make the correction here. So the correction would be, and we saw this in the video already, but let's walk through it again real quickly here. The correction would be do show run and include access would be to say no access list 111 permit TCP 192.168.0.0.0.0 255 172.16.210 established. So we get rid of that ACL. If I look at do show run Ethernet, I think it's 01. Sorry, do show run interface Ethernet 01. That's the outside interface. Was it 2? Nope. And I guess we'll Murphy's Law. It's the last interface we pick. I'm sorry, not 0. I wanted 0, 0. There we go. So this is to the server. So you can see it's in the outbound direction, right? So it's going to be checking packets leaving Ethernet 00's interface, or router 1's Ethernet 00 interface. And the way we had it, it was looking for acknowledgement packets, right? So that's another reason why the SSH was failing, is because a SYN packet is going to be denied, right? Because that established keyword dictates that it's only going to allow packets with the acknowledgement flag set. So we've got to take care of the direction as well. So let's get an interface Ethernet 00. I'm going to say no IP access group 111 out, IP access group 111 inbound, right? We want it to be inbound. And so then what was the ACL that we would need? So we would say IP access list extended 111, and we're going to say 5 permit TCP host 172.16.200.10 to the 192.168.0.0.255.255 established. Right, so and let's get out of here. Let's say exit, and actually we need to go into the interface Ethernet 00 and say IP access group 111. Was that? Yeah, 111 inbound. So do show run, include access. All right, so let's talk about this real quick, right? And so what does this say? So this says we're going to permit TCP traffic from host 172.16.210 to, so we'll put from, and then to. And the thing that's tricky about this is that it gives it's kind of what's the right word I'm looking for? It's tricky because it's like reverse logic almost, because you're looking at this and you're saying, well, wait a second, how can I SSH from the 192.168? Because that's not what this is allowing. This is allowing me to go from 172.16.210 to the 192.168 subnets. But this is the key. That's the kicker right there. That established keyword is basically stating that what's allowed to come from the host back to the initiators here, right? Back to the PCs that we're going to be SSHing from, are only packets that have either the acknowledgement flag set or the reset flag set. And remember, that SYN ACK that comes back is allowed through to set things up because the ACK flag is set, right? It's not the SYN flag that's laying through, it's the ACK flag. The SYN flag by itself is going to be dropped, right? Those packets will be dropped and the session will never be established. So again, this achieves what Peter was trying to achieve, because this is going to allow only users from the 192.168, right, to establish SSH connections. And this ACL is saying that since only these users can establish an SSH session to the server, that the server can only send packets back with the ACK or reset flag in them, meaning the session has been established, right? It's already established. And so that is what that established keyword means. And so let's do this. Let's take a quick look. First, let me exit here. I'm burning up my minutes. So let's take a quick look here, and we'll do a Wireshark packet capture to see exactly what I'm talking about. And so real quickly, just to draw, this is probably the most basic I've got a Mac here, which we're going to pull up in a second. It's plugged into a switch. I have my default gateway, which is router 1, and then I've got a connection over here to router 2. So we're going to SSH from this MacBook, right, over here to router 2. So now in looking at this, right, so this is the sort of the opposite direction of what we saw before when we had the server coming over here to router 1, going down to the distribution layer switch DSW1, right? So in looking at it in this direction, where would I put that ACL if, let's say that for whatever reason this router, sits in the TMZ zone or something, and we want the same criteria that users from this Mac can SSH over to router 2, but if router 2 is compromised, it cannot establish any TCP-based sessions with anybody else. Exactly, we would want it right there on that interface, on router 1's interface. And it's here that we're going to apply the ACL, and we're going to draw the ACL up. And the interface is, this is a 192.168.12.2, and this is 192.168.12.0/24 in here. So the ACL is going to go there on, we're going to apply it to this interface, and it's the same thing. We're basically going to say that that server, or this host IP, this router IP, is allowed, right, to send acknowledgement packets, or packets with the acknowledgement flag set back through this interface for already established TCP sessions. So how would we do this? Let's take a look at what that's going to look like. So let me clear this and let's get back to the command line real quick. So let's pull up, let's get that MacBook up. I'm sorry, I thought I had that already. It may have died out on us there. All right, so let's connect in. And actually it's 6971. Or is it 6969? And that should let us in. And the host is definitely not down. Give me 1 second here. That should be working. Let me double check the IP real quick. And that is the IP address. And let's see here why it will not let me connect in. All right, let me pause real quick and let me troubleshoot this VNC issue, and then we'll come right back. All right, that was an interesting one because I did it 3 or 4 more times with the right port, the same port number I was just using, and then it finally let me in. So here we are, right? So we're on this MacBook. The IP is 10.1.1.10. There's my default gateway. That's router 1, and you can see I've got connectivity to the 192.168.12.2. So I'm able to ping that interface on router 2. If I were to do a Control-C here, let's test. Can I SSH as admin over to 192.168.12.2? Now, nothing has been applied, right? So admin, admin, and there you go. You can see that I'm logged in here on router 2. So let's exit out. Let's kick that ping off again, and we'll allow it to continue. And so here's what we're going to do now. Now we're going to address the issue, which is the requirement, the use case, that we want to make sure that everyone from the Mac on the 10.1.1 can SSH to router 2, but that no connections can be initiated from router 2. And so we'll see the TCP setup here. So let's get into global config. We're going to say IP access list extended 101. And we will simply say permit TCP. Now remember, from, and it's kind of the reverse logic here, right? Because what you want to do here, and which is the mistake, is to say from the 10.1.1.0, 0.0.0.255, right? That's what we want to say, but that's not correct. Because remember, we're talking about the return flow of traffic. So the host is going to be the 192.168.12.2, and where do we want to allow the traffic to flow back to? Exactly, the 10.1.1.0, 0.0.0.255. So permit TCP host 192.168.12.12 back to the 10.1.1.0, and that very important keyword established. If I leave that keyword off, what's going to happen? Exactly. You would be able to come off of 172, you'd be, or I should say the 192.168, talking about the server address, you'd be able to come off of router 2 and go establish TCP connections with any of the 192, or I'm sorry, any of the 10.1.1.0 hosts that would be on the LAN, right? Let's say the user LAN. So I'm going to say established, and this is what checks to ensure that the only packets flowing back through router 1's FA01 interface from router 2, 192.168.12.2, have the acknowledgement bit set in those packets. So now let's jump onto FA01, and we're going to say IP access group, and it's going to be 101, yeah, 101 inbound. All right, so let's pull back. And look at what happened as soon as I applied that ACL. What happened? Exactly, because what is at the end of that ACL? And so remember, we've set it in the inbound direction. So all traffic that's trying to get back from router 2, unless it is TCP traffic that has an already established session, it is not going to be allowed. Right? So how could we fix this real quickly? So what I could do to fix the ping is I could say IP access list extended 101.10 permit ICMP, and then we want to do it from 192.168.12.2. And did I not say? Oh, sorry, I got a typo in there. 192.168.12.2. And we're going to let it go to the 10.1.1.0.0.0.255. And we will say, where's the... I guess we'll just leave it there. We'll let all ICMP traffic come through. So as soon as we add that, take a look at what I was going to keep it down to just the echo replies, but I just figured we'll blow it wide open because we're not really talking about ICMP here. So ICMP, right, now that's been added into the ACL, so ICMP is going to be allowed inbound from router 2 into router 1. So now let's see what happens though, because what are we interested in? We're interested in SSH. So let's kick off a packet capture here, and let's get Wireshark up, and let's see what happens. So continue without saving. So let's go ahead and start the capture. And this is actually pretty nice because you're going to see this scroll immediately. So I'm going to say SSH for the user admin over to the 192.168.12.2. And get ready because it's going to flow pretty quick here. And there it goes, right? And so let me stop that. Let's go back up here. And you can see SSH version 2. So here we are. The very first packet. Now remember, this isn't coming in from router 2. This is sourced from the MacBook going to router 2. So in the outbound direction, do we have an ACL on router 1? We do not. Remember, that is an inbound ACL, not an outbound ACL. So the synchronized packet, the SYN packet, that goes out with the window size of 64K and the maximum segment size for TCP of 1460. So it goes out and it's trying to do the three-way handshake. And so then what do we have next? Exactly. The ACK bit is set, right? ACK is 1. So the ACK is on. So this is allowed through because the established keyword states the ACK flag must be set, or the reset bit, right? Or the reset flag. They've got to be set. If they're not set, they're not going to be allowed to come back through for TCP connections. And then we have, so there's the SYN ACK, and then what do we have? The ACK from the MacBook back to router 2. Now, let me ask you this. All of these packets you see after that, what kind of packets are these? Right? We've got some Diffie-Hellman stuff, but what do we have? ACK. ACK flag is set. ACK, ACK, ACK. There are no more SYN packets, right? If I was to kick this back off again, and let's pull up this session here, if I was to put the password in, look at that. It's generating a whole bunch of, and we'll say show run, and this is going to generate even more TCP communications back and forth. But what flag is set in every single one of these packets that's being allowed back through? Exactly, the acknowledgement flag. And so hopefully this has clarified any confusion that that established flag may have caused. And I know that it did, right? Because that was definitely not an easy ask, right? In that activity. Definitely very confusing because they stated as he applied a security feature, and we see that there's an ACL there, but the established flag definitely causes some confusion because of sort of the reverse logic where you're not saying allow the SSH or the TCP connections from the user's PCs to the server. You're saying allow the server to communicate only with packets that have the acknowledgement bit set when there's an already established session, right? And so from router 2, if I was to try to initiate an SSH connection, that would be denied because how is that TCP session going to be started? Exactly, with a SYN, a synchronized packet. So let's go ahead and drop this down. So hopefully that makes sense. Again, I wanted to give you guys a deeper dive look at that established flag and talk a little bit more about exactly what that flag, that option I should say, what that established option when used with an ACL, an extended ACL, what does that mean? And what's the behavior we're going to be looking for? All right, guys. Thanks so much for watching, and I'll see you on Thursday night.